Welcome to this explainer. Today we are looking at something just absolutely fascinating. We're going to explore this totally unexpected, kind of brilliant connection between the heavy, stifling weather of a concrete city and the hidden biology right inside an aquarium. It's essentially a story about how simulating seasonal triggers can create these explosive biological reactions.
So you might be asking yourself, what on earth does stifling heat have to do with fish keeping? It's a bit of a pattern interrupt, right? Just imagine that feeling for a second. A super hot, stagnant city night where the air literally refuses to move. Now imagine taking that exact heavy, oppressive feeling and using it to understand the micro-world of a fish tank. That completely unexpected link is exactly what we're breaking down today.
Okay, let's dive right into this with Section 1, the urban heat island and city concrete heating. To start, let's look at the macro environment right outside our windows. According to our source material, imagine we're smack in the middle of the rainy season, right? But the weather pulls this incredibly ironic twist. Instead of cool rain, the night feels unbelievably hot and stifling. This really high humidity rolls in, which completely stops your sweat from evaporating. The wind just utterly slows down to a total halt. The air just sits there. It feels trapped, heavy, literally like stepping into a sauna. And that brings us to our core definition, the urban heat island. This is a crazy phenomenon where the city's concrete acts like a giant thermal battery. It absorbs all of the sun's intense heat all day long and then, pretty cruelly, just bleeds it out into the night air. When you combine that with the stagnant humidity we were just talking about, it creates an environment that feels entirely stuck in place. No movement, just oppressive, heavy heat. Now, what's really interesting about this next part is how we pivot from that massive macro city weather down to the micro level. Let's look at Section 2, simulating the monsoon with water top-ups. Let's walk through this sequence. Step 1, we've got that stifling, stagnant heat outside that we literally just defined. But then, Step 2 happens. As a fish keeper, you go and do a regular water top-up in your indoor tank or maybe an outdoor pond, and you introduce a fresh influx of cooler water. And boom! Step 3. Even though the air outside is totally unmoving, you're actively mimicking the rainy season right there in the water. You're abruptly breaking that stagnation and simulating a localized monsoon. This brings us to Section 3, the Zebra Cichlid reaction and biological triggers. You see, this sudden environmental shift isn't just about changing temperatures. Oh no, it acts as a direct, instant biological trigger for captive fish. I absolutely love this specific observation from the source material. Right after one of these fresh, cool water top-ups, the author notes that, quote, the male began relentlessly chasing the female to mate, so much so that she is still hiding behind a terracotta pot. It's a kind of funny visual for sure, but man, it proves a powerful point. The fish didn't need some slow, gradual change. That sudden influx of simulated rain signaled directly to their biology. Hey, the monsoon is here, the environment is refreshed, it's time to breed. And it happened almost instantly. Let's transition over to Section 4, the biological switch. Are stable states actually ideal? This leads us to a much broader, honestly, more profound concept. It really makes you question something fundamental. Are constant, perfectly stable conditions actually ideal for sparking biological processes? Let's just pose this hypothesis for a second. Would a continuous, ongoing water flow to simulate a moving stream increase the likelihood of mating? Think about that. We so often just assume that creating a constant, pristine, ideal state is the absolute ultimate biological trigger for success. I mean, if a little fresh water is good, wouldn't a constant, unending stream of it be way better? Well, the answer is actually no, and here's why. And this brilliantly illustrates the contrast. On one hand, continuous water flow absolutely has its benefits. It helps with oxygenation, it keeps the spawning site physically clean. But on the other hand, it's the sudden change, the abrupt top-up of fresh, cooler water that actually mimics real rain and physically flips that biological switch. Stability maintains the environment, sure, but it's the sudden disruption that triggers the real action. So, the crucial point is this. The change in conditions is actually more important than the conditions themselves. This is such a fascinating takeaway, and honestly, it stretches way beyond simple fish keeping. In biology, we totally obsess over creating the perfect, steady state. But time and time again, we see that it's the contrast, that sudden shift from a stifling, stagnant heat to a refreshing splash of cool water that truly sparks a profound biological response. Which leaves us with a final, kind of provocative thought to take away from this explainer today. If a sudden environmental shift flips the biological switches in fish, what sudden changes are needed to flip ours? Think about it. If you've been feeling a little stagnant, maybe trapped in your own kind of urban heat island, maybe what you need isn't to meticulously maintain a perfectly stable routine. Maybe you just need a sudden change to flip your switch. Thanks so much for joining me on this explainer. Keep seeking out those fascinating connections, and I'll see you next time.